Hey everyone, it's been it's been a minute since we've done one of these. Today's topic is going to be polymorphism and inheritance and all the good stuff that goes with it. The idea really is that just diving into kind of a popular programming question, especially with interviews and that sort of thing. More importantly, though, I want to try to give just a decent example where a lot of textbooks and companies might not really get into it or might not use it well. I will be using classes and inheritance, so some familiarity with these concepts is going to be best. If I gloss over a concept that you feel a video should be made from, feel free to subscribe and request it, or just request it. I am intending to get back into doing this a little bit more often, so good suggestions should be followed up with videos. This probably will be a somewhat long video, so I have quite a bit of this already set up and waiting for us on the side, and I will try to speed this video up where I can and cut out some bits and pieces. So if it's a little bit more jerky than normal, it's to save time, and if I get into like a long typing debugging, I'll try to either cut it or speed it up. One of the suggestions I have had in the past is to just that it's a little slow to watch it at 1.5 or double speed, which I do that when I watch a lot of videos, so that doesn't bother me at all to A, try to help you out, and two, if that's the way you watch it. And that's where we'll start for today. So just kind of the class setup here. I will try to give you just a little bit of time here and there to catch up if I feel like I am moving quite quick for those that are just trying to follow along. It's just a regular C# console application. Off the top of my head, I think it's a .NET Core. Yep, it's Core 2.1, but this should work for full framework, and I would assume just about any other version of .NET. Should be nothing special there. I have in the startup for the main method, just went ahead and added a console.read key so that as we run things, it doesn't exit the program. We can actually see what's happening. See, the first thing that I wanted to do was give kind of a really simple example, and I'm going to do that by creating this animal.cs file, and then I am going to just go ahead and create a super simple animal class. So very straightforward. I have an animal, and because I usually organize this differently, we have just a property here for name. In the default constructor, I'm going to go ahead and give a name of animal, and then I'm adding a method here for speak. So next thing I'm going to do is I'm going to go back to program, and I'm going to create a method here, and I'm going to call it, it's going to be a private static void. I'm going to call it, say, animal things, and I'm going to accept an animal name that's a string, and I will never actually probably be able to spell speech right the first time, but I can always tell when it looks weird. I hope so, at least. All this method is going to do is write out to the console whatever the animal's name is, and then whatever it is that the animal says. So for our animal class that we created, it should say, I don't have a good thing to say. And we're saying that just because we're kind of using that as a generic-ish class at this point. We don't have a specific implementation we want for that animal right at the moment. So we should be able, let's also go back to animal class, and let's create a second class. And I'm doing it here because for this particular level, I didn't want to create a second code file. And all it is a public class dog inherits from animal, we are hiding the speak method and using woof woof instead, and we are not assigning a name for it. So the first thing we're going to do is let's go ahead and let's just create a basic animal real quick. So we're going to say animal is a new animal. And you know what? We know that it's going to do the things that we expect it to because everything's there. And let's also do let's do a dog. And that's a new dog. And his name is going to be Fido. And, whoops. And that is it. And then we're going to go ahead. And one thing I do want to do actually is I want to handle real quick, not necessarily always the best way, but the way I would expect to see it most of the time, where if wow, if animal name is null, because a lot of the times if a property or a variable or anything is null, weird things happen. So we're going to go ahead and pretend like that's an expected thing. And so if this happens, we're going to throw a new argument, null exception. Otherwise, we're going to write out the animal name and speech. So first, let's go ahead and do say animal things with animal.name and animal.speak. Okay, and when we run this, it's going to do exactly what we expected it to. Animal says, I don't have a good thing to say. Nothing super interesting there. But let's also try it with dog. So say animal things, and it's going to be Fido name and Fido.speak. So here you can see that because we're inheriting and just the way it's working, they're both seen as an animal. So this works, but you know what? That's my mistake. Let's not give them a name yet. Okay, here we do get our exceptions. So we're getting that because that's kind of what you would expect with a null most of the time, at least. Go ahead and close out of this. We'll bring back Fido having a name so that we don't continue to have the error. All right, so on Fido not having a name, there's actually a few different ways we could handle it. One is we could do some sort of default method implementation where we could say animal things. If animal name is null, then do some fun things. We could also do it in the dog class where we could say something like, we could change the accessor for dogs where if we get the name and the name is null, return an empty string. I mean, there's a lot of different ways we can handle it, but it kind of gets into one of the problems with when you do inheritance this way, where it's a little bit tricky sometimes to have it behave the exact same way. We could try doing some of these things at the animal level as well, but as you can see, even though a default animal constructor does this, it's not always going to happen with the things that inherit from it. Although we should be able to do this and then come back here and not use Fido, and we still get just animal. So we can get it to work that way as well. Let's undo that. Undo the hiding. Is that we could also have another developer, and we're going to pretend like this dog that inherits from an animal is in a separate code file, maybe even written by just some other developer completely, and he's got a requirement that his animal slash dog that he's working on right this instant has another behavior that he's expecting. He wants the animal to be able to jump, or in this case, yeah, we'll leave it with jump. He wants to be able to jump. So here, and we're going to create one more dog real quick. We're going to call it Sparky. And we have a new dog, and its name is, whoops. All right, name is Sparky, and we want Sparky to jump. All right, so whoever had this thing is going to get exactly the behavior that they would have expected. Sparky jumped 15 feet. It seems to work great. Where it might get a little weird, though, is if you started to try to use something like inheritance and polymorphism. Not exactly polymorphism, because part of the modern definition of it is going to not quite apply, and we'll get into that in a little bit. But if you expected to have like any animal that would behave exactly the same way, and say you pass it into an external class, or there's a dependent class, or even a database method, you should be able to do something like this, where you have all these animals. We expect to behave exactly the same way. So now let's do friendly animals. Whoop, I do that way too often. Okay, so let's go ahead and say for every friendly animal in animals, we want to say animal things, animal dot name, and animal dot speak. We'd have no problem with this. And even here where we've got Sparky.jump, let's assume somebody wrote some extension method, or really who knows what, and we are expecting to be able to treat all of the animals that inherit from animal the exact same way, because look, it passes this test at least. We could even say something like a friendly animal Okay, see, we should be able to say all these things. But what we can't do is jump. Just an implementation thing. Again, there's some different ways that you can try to get this to work a little bit more consistently. But what if there was a way that you could more or less force it to? And that's really where polymorphism starts to come in. So we currently have inheritance. So we currently have inheritance, but we don't have polymorphism. So our next step is going to be to get polymorphism to work. And one of the key things that we can get from that is that it's basically going to act like a contract, where we can pretty safely assume that everything's going to work exactly the same way. So I'm going to go ahead and get rid of the stuff that will write out so that when we run it, we won't see things. All right, and let's see. So where we want to start next, let's go ahead and go to, I created another class here. This one is actually going to be our interface. So in iCreature, I'm going to create an interface of iCreature. And here I do have my properties more or less the way I like them, where I have speed, name, environment type, and move. Now, if you haven't used an interface before, one of the important things is that you don't actually do anything in the interface. It's only a contract. It's just a way to kind of force things to happen. Other points, you need a return type, and everything is going to be public by default. You can't have private members or methods in an interface. The last thing is I do have environment type. Environment type is a custom enum. So here we have environment type file, and in there we have just a public enum environment type where I went ahead and put land, air, sea, and fresh water. So I'm not going to need that file again, so I went ahead and closed that one. All right, and then for the next bit, I'm going to also go to land creature. Land creature is going to be a class, and this class is going to inherit from our interface iCreature. So one of the things that you'll notice right away is if you tried to actually type this out, which probably wouldn't have been a terrible idea either, is that iCreature is going to complain that you're not implementing all of the members, properties, methods, whatever you declared in that interface that you're inheriting from and aren't here. If you let Visual Studio or ReSharper do it for you, it will create the method or the field or whatever for you, but everything is going to throw in how to implement it an exception. Could be good. Generally not what you're actually going to want. So I'm going to restore the speed name, and then in the default constructor for land creature, I'm also going to go ahead and set the environment type to environment type.land. I thought I had moved this up. Okay, and then in move, I have a method for just writing out the name of the creature, and if the name is null, then we'll write out the name of the type, and then moved by their speed. Pretty simple there. One other thing I'll go ahead and do in program, so back in our main method for the actual console application, I'm going to go ahead and create a new instance of iCreature, and we're going to call it land creature. And if this is new to you, you'd probably expect to see this. But that's not the way this is going to work. It's going to instead be a land creature. And you actually could take a similar approach with an inherited class. But this is actually pretty important for what we are trying to do here, where you're going to force that contract and force a standardized usage of the object. So here we have a iCreature that's a land creature, and we're going to go ahead and give it some properties. So its name is going to be land creature, and its speed is going to be 1. And we're going to go ahead and make land creature move. So there we go. We have land creature moved by 1. It's exactly what we would have expected to have seen. And then if we, for whatever reason, didn't instantiate it with a name, we would see land creature. That's the name of the type. So it worked exactly as we would have expected. But I don't need that right now, so I'm going to get rid of that. Let's see. Let's also go ahead and create one more class real quick. This one is going to be our dinosaur class. And here in dinosaur, going to be a very, very simple class. And actually, you know what? Let's type this one out just for the fun of it. So we're going to have a class, and it's going to be dinosaur. And dinosaur is going to inherit from land creature. What? And I creature. Okay. And then eventually I will learn how to type. And then here I'm going to do a default constructor for dinosaur where his speed is going to be 5. 5 is the... Yep. Okay. All right. So what you might notice here is that we don't have to implement all the features of the iCreature type. We are assigning a speed in the default constructor, but we are not assigning it a name, and we're not doing a handful of things that we were doing in this case, land creature. If we go back and look at it, where we're setting an environment type and a move method implementation. Because we are inheriting directly from land creature, everything that land creature does, dinosaur is going to do by default, unless we do something to tell it to not. So we're going to go ahead and add a method just to kind of show something that we wouldn't want to do. We're going to, first of all, mention that this is bad in case you scan things. This is bad. And then we're going to do, and then this is probably not the way you would ever really do anything, but because it's a complex application and a video, just to kind of teach you a handful of things, we are going to do it. All right, so there we go. We have an eat humans method where when we tell the dinosaur to eat humans, we're just going to write out of the console, nom, no humans died of dysentery, dinosaur ate them all. Nothing super awesome, but it is going to prove a point here. We're going to go ahead and go back to program again, and here we have land creature, and we have a land creature that moves. And let's go ahead and not have that show in the console anymore. And then let's create a new dinosaur, which is a new dinosaur. And so here we're using it just like we used the animal and the dog class earlier. And you know what, Rex isn't doing anything. I don't need this right now. So let's go ahead and have Rex move. And let's also then have Rex eat humans. So still, everything works exactly how we would expect it to. The dinosaur moved by 5, and nom, no humans died of dysentery. Dinosaur ate them all. So everything is exactly as we would want it. But this isn't the way we would actually want to do this. One of the important things is that we want to use a contract. So we're going to instantiate this as an iCreature. iCreature is a new dinosaur. Rex can still move, but Rex can't eat humans, which is exactly what we want. We want to force none of the implementation to be at that class level unless it's at the interface level first. So we're going to go ahead and do another example. Rex, we don't need you to move anymore, but we're going to go ahead and create another class. This one is going to be in the shark file. Shark, is going to be a copy and paste from what I've prepared. Okay, so we're going to create a shark class that inherits from iCreature, and then inside of the iCreature we're going to go ahead and fill out our implementation stuff. Have these up here. Shark is going to have a different environment type. He is also going to have a speed quite a bit higher than Dinosaur. Dinosaur is apparently not very fast. And we're going to do this, where we've got Shark moved at a quick speed, X spaces, however fast he moves for that one. And then let's go ahead and go back to program one more time, and then we still have Rex here, and we're going to go ahead and create a list of iCreatures. And I'm going to add Rex to this. And I'm going to also add a new shark, and shark's name is going to be Stan. Okay, and then for the next thing we're going to need to do is I'm going to use a little bit of link. .NET Core does not include link by default in your using statements. So do make sure if you're using .NET Core especially, but just in general, that at the top of the file for your using statements you are including system.link. So using system.link is right there. And then let's also add a new class down here. This one is going to be just a class for a specific movement method that I'm going to want to use. We're going to call the class movement, and we're going to include a swim method, and this is actually going to be an extension method. Again, not everything I'm doing right now is actually best practice. There is a naming style violation most likely here where I'm swimming with a list of creatures, which seems weird. Just barely, not the worst thing, but it does seem a little bit weird. And then I'm going to go ahead and cheat again because I do have a lot of this prepared to try to save us a little bit of time. I'm going to go ahead and do a couple of things in here. First, public static void swim. Oh, I have this at the wrong level. Okay. Yep. And another issue. This should be a apparently public interface. Okay. Okay, here we go. So the first thing I'm going to do is we are passing in for the extension method, a list of iCreature, and we're calling it creatures. So for creatures where the environment type is C, I'm going to get a list of those, mostly so that I can use the for each method. And then for each creature, in creatures basically, we're going to do creatures.move, where we'll see how quickly they moved, how much. And then after that, we're going to do creatures.where, and because we're swimming, creatures.where the environment type is land, we're going to write out that the creature could have drowned. Luckily, he didn't move. So when we run it, I have to do better. All right, so when we run it now, we're going to see shark moved at a quick 40 spaces, exactly what we wanted to see. But we also get that our land creature could have drowned, but it doesn't say who our land creature was. Something could have drowned, luckily he didn't move. So this is one of the nicer things about actually using the contract and the inheritance like this. One, we could have done that with classes and inheritance, but it would have been a little bit messier, especially when things start to get a lot more complicated. But let's go ahead and fix it for now. We can go back down to this method, the movement swim, and then here, let's do, if that's null, let's creature dot, whoops, get type, and we just want the name. So here, dinosaur could have drowned. Luckily he didn't, or luckily he just didn't move. So you can't drown if you don't try to swim, I guess is what I was thinking. So that works. But what if we could try to fix it anywhere, or everywhere, more importantly? Okay, so what we're going to do is we're going to go ahead and fix that for all, where if the name is null, return something a little bit more useful. We're going to go ahead and do it for all instances of land creature. It doesn't fix sea creatures right now, but we'll get to that in a little bit. So let's go ahead and go back to land creature. We do have shark Rex in there. Yes, we do. Okay. So let's go back to land creature. Land creature, I'm going to make one slight change to this. I'm going to have a private name. And then I'm going to change this out. So instead of doing just to get set, I'm going to return that. And then for sets, it's going to be stat name equals value. So more or less, so it's going to work exactly the same way. The key difference here, sometimes it just doesn't look right. So the only thing that's going to happen here now is just that when we ask for the name, we're going to get this local variable instead, unless it has not been set. If it has not been set, then it's going to return this. So anything that inherits from land creature is now going to work this way. And we can prove it by, let's go ahead and add land creature to our thing. Land creature. Okay, so now we should see Rex won't swim, land creature won't swim, but Stan will swim. So here we go. Shark moved to add a quick 40 spaces. Dinosaur could have drowned, luckily didn't, and land creature could have drowned. Oh, we set his name there. Let's undo that. Land creature. All right, here we go. Land creature could have drowned. Luckily, he just didn't move. So we're back to having one implementation for anything that is a land creature. And actually, we could even prove it with dinosaur. Where did we give dinosaur a name? Rex is... Oh, that is his name. Dinosaur. Let's make sure. See, it works so well. I thought I had already given Dinosaur that ability all on his own, but it looks like Dinosaur is actually just working exactly how we want it to. What we don't have is Shark working the way we want to. So let's go ahead and create another class. This one is going to be Creature, which normally this is probably the way you would have started things off. It's going to be our default implementation for pretty much everything. So it's a class creature, iCreature, or inherits from iCreature. And we're going to go ahead and give all of our properties, methods, everything we want from anything that's a creature, how we would expect it to work. So creature is going to have the name that's set up exactly the way we wanted. And here we're using creature name as the private property, but we do have the accessor here called name still. So iCreature is saying that we have to have a property for name. This is fulfilling that requirement in the contract. We still have our environment type. We do not have a default constructor here. That might be something that we want to fix, but for right now, it should work just fine. We still have our method for moving, and we still have our method for moving, where we have moved whatever the guy's name is, moved over through and across at his speed. And we're going to have everything inherit from this. So we're going to start by going to Shark. And Shark is going to inherit from creature and then iCreature. And then land creature is going to also inherit from creature and iCreature. And dinosaur can still inherit from land creature. That's fine by me. I am okay with this. Let's see. What we also should be able to see here is now we have Shark, and Shark is still kind of set up to do what we were doing when it was inheriting from the interface directly. But because we now have a default implementation in an actual class, we don't have to have some of these things. For example, everything that's currently green in my version of Visual Studio, these are members that are, as Visual Studio says, unintentionally hiding. We can do it on purpose, where we do public new. Whoa. There, and now we've hidden speed on purpose, but we don't need to hide it. Here in the default constructor, I am going to still go ahead and assign these properties, but these properties are actually on the creature, and then we don't need move anymore. You know what? Let's keep move. So Shark is still going to do it, but we're going to hide the creature move method intentionally for Shark. What we're going to do slightly different, though, is let's go back to Dinosaur. What is Dinosaur doing? Dinosaur, we've already hidden these properties that we don't want, and for land creature is also not incredibly happy that we're doing these things. We don't need land creature's move method. We're going to keep the default constructor because for any land creature, I do want to make sure that it knows it's an environment type .land, and I don't need any of this. Okay, so land creature, Shark, Dinosaur. Everything does look good, a little bit simpler. Go back to program. We'll notice that nothing here has changed, and when I run it, we get Shark moved at. This was the move method that we did hide and override with our own version of the move method for the Shark implementation of creature. Dinosaur could have drowned. Luckily, he didn't. He just didn't move. And land creature could have drowned. Luckily, he just didn't move. So that is all still working. We could even move a lot of this logic into the into one of our. We also could move this logic into the creature class and then force the contract through the interface, and that would have done basically the same thing. Some of the nice things, though, that we do have is that whenever we do need to create a new implementation of iCreature, let's say there's a new requirement where, let's see, what's a fun animal? hey, it's a unicorn. So we have to create a new unicorn. And okay, we have to create a new unicorn. So we have a unicorn that inherits from creature and a night creature. We go back to the program. Let's add to this unicorns. You know what? We're going to give him no properties at all. Let's see what happens. So all we've done is create a class. We haven't set up an implementation of any sort. Let's assume that maybe the properties are there and all we have is a REST API that takes whatever's passed in, finds the best matching class, wraps it to that, and we expect the implementation from there on out to be perfect. Similar thing, all the properties might already work the way we've designed it. And here we go. Unicorn could have drowned. Luckily, he just didn't move. So it works exactly how we would expect it to without actually doing anything for it for the specific implementation of Unicorn. Some of the benefits here is that not only is it a lot easier to set up a new implementation for something that maybe we didn't expect when we were originally writing everything, but we expect a certain pattern. It's also a lot harder to encounter unexpected scenarios that haven't been tested. If you write a interface and a creature and you test everything that that creature can do, you shouldn't be able to experience weird errors and scenarios, at least not very easily and without doing other odd things, because everything should behave exactly the same way, and that's one of the benefits of polymorphism. Dinosaur, shark, unicorn, they all do the exact same thing from a code standpoint. We also have a lot less logic and clutter in our business layer. This is more or less what I would consider probably close to the business logic layer. There might be another one where I'm saying do this thing, then passing it to an actual business logic layer, doing a lot of work with it, querying a database, that sort of thing, and then returning it back for maybe like a view for an Angular site or an MVC site. But we clean it up a lot more because all of our logic is far away from where we're doing the straightforward stuff, and you should be able to come through and just read it very easily. And then the last thing that this really sets us up nicely for is if we decide to implement inversion of controller dependency injection. A lot of that is all the hard part of it is already done using this pattern, where you don't have to come back in and set up all new things just for the purpose, or rewrite tons of code just for the purpose of getting your dependency injection or your inversion of control to work correctly. That's really it for this particular video. I do hope that it helped out a little bit. The examples probably aren't perfect, but it should give you a pretty good idea of what is possible and what this can do. If I did go over anything incredibly too fast, or if I touch a topic that you'd like to hear more of, or if you just have a completely new topic that you'd like to see a video about, feel free to leave a request. One of the things I would really enjoy is getting a handful more subscribers. That way I have just that extra encouragement to keep doing some of these things. Thanks.